So now we're asked to find if this set of polynomials is linearly independent in P2. So really we do the exact same thing as we would if it was column vectors. We'd set up our homogeneous equation. So A times the first vector, which in this case is a polynomial, plus B times the second vector, plus C times the third vector, and set it to 0. And basically what we're looking for is, are there non-trivial solutions? So is there an ABC that's not all 0? So the best way to try to figure that out is to actually regroup everything for the coefficients of x squared, x, and the constant. And so if I do that, I will get A plus 2B plus C times x squared plus negative A plus B plus 5C x plus 3A plus 5B plus C equals 0. And the only way for this to be true, emphatically, like as a polynomial equation, and what that means, like always equal to 0. So when we say 0, we're not like solving the polynomial equation. We mean that this is the 0 polynomial. So it's 0x squared plus 0x plus 0. So it's the polynomial that's always 0. So what that tells us, though, is that we do get this nice system of equations. A plus 2b plus c equals 0. Negative a plus b plus 5c is 0. And 3a plus 5b plus c equals 0. We can solve this. We use matrices to solve this. 1, 2, 1. Negative 1, 1, 5, and 3, 5, 1. And if you're following along, it's very similar to how we set up those matrix, the ones with vectors in Rn, where you would take the vector and just make it the columns of the matrix. We're basically doing the exact same thing here. Those coefficients become the columns in the matrix. It's really similar. Yeah, we're just going to do our row reductions here. So I'm going to add the first row to the second row, and then I'm going to subtract 3 of the first row from the third row. And what we can see is we are going to get some repetitions here. If I reduce this, I'll get, these are going to wipe each other out, and I'll bring the other one up and make it positive because I like them better. And right here, this is enough to actually make our conclusion. I could very well just say right here, there are going to be free variables. Pointing to the wrong column. So this is a free variable. So there are non-trivial solutions. And therefore, we can say that the set is not linearly independent, or if you like, you can say it's linearly dependent. We do know that from the free variable, so we should be able to actually find an arrangement of the 3 things that add up to 0. And in fact, we could use something like any non-zero solution. We can obtain it by solving for your parameters of this solution here. But an easy one would be 3 times the first vector plus, minus 2 times the second vector, and plus the third vector is equal to 0. And you could definitely obtain this easily by just solving this here, and then just plugging in the t, or your parameters s or t, just plugging in like the nicest one to make them small integers. But yeah, we have a non-trivial solution. It's not linearly independent.